right, folks, so we're going to start, like I said, our new unit on functions today. And we have to decide, there's several ways to write functions. One of them is an equation, which I think we're most familiar with, y equals x squared, that kind of thing. But a mapping is what you see here, and a mapping is also a way to describe a function. And so if I look at these three mappings that you have drawn up here, and we'll say that they go from x to y, tell me yes or no whether they're functions or not. I will tell you, give you a hint. Only one of them is. I'm sorry, I'm a liar. Only one of them is not a function. Okay, so we have to make a decision. The big key to a function is something can't repeat. Do you remember which one? The x's cannot repeat. Good. We've done this before. Remember at the beginning of the year we did this a little bit? So we know that because the x repeats here over and over and over again, that this one is not a function, right? But for this one, there's only one x. This one, we have only one x. There's a couple. The y's have a couple values. Can the y's repeat? Yeah. That's okay. All right, so we know these things. So the first two were functions, the last one was not. All right, we did this before also. Another way to write a function is to write them as points. Remember this part? We did this at the beginning of the year. Which ones of these are functions? It's kind of hard to see in the back. I apologize. The first one is, remember what we're looking for. We're looking for the x's only. Do those repeat? So it's a function. Does this one repeat? So is it a function? All right. How about the last one? It's not a function because we already right away, they are all ones, aren't they? So not a function. The hard part, if you remember from the beginning of the year, is when we looked at graphs, right? How can I tell whether they are functions? Looking at the first three only. First three only. One of them is not a function. Which one? April, raise your hand. It is the middle one. Why? Patrick, what did you say? What kind of a line? Right. So it's the vertical line test. Remember this from the beginning of the year, that VLT? Okay. When I draw a vertical line, it hits in two places, so it's not a function. But I can draw as many vertical lines here, only hits it once. As many vertical lines here, only hits it once. Using that idea, tell me what you think about these last ones. This last one's kind of hard. I'm going to draw these dots in red so you can see them in the back. Only vertical line, not horizontal. Okay? Horizontal is something called a one-to-one function, which we're not worried about. The middle one, yes or no? It's not a function. I agree. So I agree. That one's not a function because it hits it twice. How about the first one? Is it a function, yes or no? Yes. It's a function. And how about the last one? Even though it's just dots, it's still okay. It would not be a function if I drew this dot, though, would it? Because this vertical line would hit both of those dots at the same time, right? But they're not there. So that red dot's not there, so it is a function. Okay, so we're good. So we did this before, right? We know how to do it. So we're going to talk, we already know about how to, we've already done this part. So we're going to take functions and we're going to add and subtract and multiply and divide them. Okay? We already know how to do this, but we're going to specifically describe what's called function notation. And this is something you should probably write down. Okay? So here's an example of what we're looking for. This notation is what you're going to see. F plus G, F minus G. Sometimes you'll see F times G. You're going to also see something called F circle G. That stands for fog, which is a composition. We're going to learn that soon. And Goff. Inverse. We're going to learn a lot of different notation. I did. What I highlight is what I want you to write. Okay? I also have to be given what f of x is and what g of x is. We really don't use in function notation the y's. The same thing as y is f of x. f of x is the same thing as y. It's just that f of x is called function notation. Okay? And that's what we're going to be dealing with here. So if I look at the very first one, okay, this one here, I'll put a 1 with a circle on it. Which one is f plus g? If I look at the first row here that I have highlighted, what would represent the same thing as f plus g? I want to take the f and the g and combine like terms. That's really all I'm doing. What do you think, April? Sorry, honey. The third one. So if I took 2x squared plus 8 and I added x plus x minus 3, I'm going to basically be combining like terms. And I have 2x squared plus x plus 5. So isn't that the answer? Because I'm combining the 8 and the negative 3. Those are my like terms to combine. So when I add fractions, when I add functions, it's literally just combining like terms. Nothing more than that. But when I subtract functions, negative 8 minus 3 is 5. I just combine like terms. The negative 8, or the 8 minus 3 are the two terms I can combine. I cannot add an x squared to an x, so those stayed. But I can add the 8 and the negative 3. Christian. Because that is what f of x is. I'm given that information. I took 2x squared and g, I'm sorry, I took 2x squared and x minus 3 and I just combined like terms. I added the functions together. Oh. That's all f plus g means. Add them together. Okay? Now I'm going to look at f minus g. Sorry, f minus g is down here. This one I have to be careful about because I'm subtracting all of g. And it's notorious, someone's going to forget to subtract something. So I really think it's important to use parentheses. So here's what I'm going to write. I'm going to take f, and I'm going to subtract all of g. So I'm putting g in parentheses because I'm subtracting all of it. And what am I going to go in? What's going to go in there? Whatever g is. So what's g? X minus 3. Why are those parentheses so important? That negative goes with not only the x, but doesn't it also go with the 3 as well? There you go. If you want to, but if you're going to skip steps, you're probably going to make a mistake. So just be careful. I really, really think it's a good idea to write the minus in the parentheses because so many people tend to, I'm telling you, I've taught for 20-some years. It's just something I see all the time. Because I am. What's your problem? What you need? Why did you switch from that problem to that one? Because there's two different problems. One was f plus g, and a different one's f minus g. It's just two problems. And sometimes I'll ask you for one, sometimes I'll ask you for the other. Minus, I want a minus parentheses. I could have said plus parentheses. I could have put parentheses here too. Right? That wouldn't have changed anything. But I didn't need to because I don't have to worry about distributing a negative sign. Okay? Well, 2x squared, that doesn't combine with anything. So let me just rewrite it with that when I distribute the negative, okay? When I distribute the negative, I'll write underneath it. I get 2x squared plus 8 minus x plus 3. Because I distribute the negative to everything in the parentheses. I subtract all of g. So the only thing I can combine, again, are these two things, right? Those are the only like terms. So it's going to be 2x squared minus x plus 11. Very good. That would be f minus g. Okay? We good? Okay. We good? When we multiply and divide, it's really not that hard. It's just a matter of notation. So again, we're going to have, let's take the same ones. Let's not, since you already had these written down, let's deal with the same ones. Can we do that so you don't have to add more notes? Let's do f times g. This is normally how it's written. Be very, very careful because there is a different notation that we're going to learn after spring break that looks like this. This does not mean multiply. So it has to be a closed, filled-in circle to mean multiply. And that's called composition, and we're going to learn about that after spring break. Fog, yeah. I'm just telling you to close your circle. That's all. All right, fine. What does fog mean? It'll tell you it's like some kind of cloud that's low to the ground. Fog, F-O-G. Fog and goth. We'll deal with that after spring break, okay? But just make sure your dot's filled in. That's all I care about. So let's think about what f, let me rewrite what f was. F is 2x squared plus 8. So we have this written down. And then what was g? G was x minus 3. All right. If it says to multiply these functions, which it does here, you're literally just going to do that. You're going to take 2x squared plus 8, and I'm going to multiply it times x minus 3. But you're going to have to do the work and actually multiply it out. I'm going to have to distribute everything and multiply and combine like terms. You're going to have to do the work. Don't leave it in factored form. So I'm going to take the 2x squared and distribute it. I'm going to take the 8 and distribute it. Right? So let's do that. What is 2x squared times x? 2x to the third. What is 2x squared times negative 3? Negative 6x squared. What is 8 times x? 8x. What is 8 times negative 3? 24. Negative 24. Good. That's what my problem is. Combining like terms. Are there any to combine? So that's my answer. I'm done. If there were things to combine, I would. But there weren't here. Okay? So I just leave it. The other thing that you can be asked to do, so far we've added, we've subtracted, we've multiplied, what's left? Divide. Okay? So the other thing I could be asked to do is f divided by g. Will, look up here, f divided by g. That would be the last thing I would ask you to do. Okay? F divided by g. This one's okay. The only thing I have to be worried about here is the domain. So I'm even going to write that and highlight it or circle it or something. I have to be aware of the domain. Okay, so I'm going to write that. What did I have to be aware of with subtraction? With the subtraction, I had to be aware of the parentheses, right? And with division, I'm going to have to be wary of the domain, and I'll tell you why in a minute. F divided by g, it's not hard. You're literally going to put the numerator as your f, if it's f divided by g. So f goes on the top, and g goes on the bottom. I know that was hard. I know that was hard. I know it's like, it's a struggle, but we're done. I know that was rough. I'm not trying to challenge you. Are you challenged? Okay, so there's a little bit more, but not bad. What it almost is the answer. It almost is. if I could factor the top, and maybe something would cancel, I would do that. But I can't, well, could I factor the top? Just a GCF of a 2, but nothing else. Nothing's going to cancel is my point, right? But the thing I have to be careful of is the domain. What can't x be? Good. Because you can't divide by zeros. You have to write that. You have to say this is f divided by g, but x can't be 3. So that's the only thing you have to add. Why can't x be 3? Because you can't divide by 0. If I put a 3 down there, I'd have divide by 0. If I do anything on my calculator where I divide by 0, 3 divided by 0, it yells at me. Okay? Can't ever divide by 0. I know it is. I'm going to change it. That's it. That's not bad, right? We can do this. All right. Right, it would be it would be a vertical asymptote, which is why it's a domain restriction, right? We have to be careful about that. All right, so I'm going to give you 2 more here. Let's see. I don't even know what this is. No, we're not doing composition today. All right, I'm going to give you 2 more. I'm going to give you an F, and I'm going to give you a G, and I want you to find all these things. I want you to find F plus G. I want you to do G minus F, so the order is going to matter here. I want you to do F times G. Notice that's a filled in. And I want you to do a G divided by F. That's not that hard. So I'm going to write your functions. That's it. Okay, so I've given you your 2 functions. I want you to go ahead and add them, subtract them, multiply them, and divide them. I'm going to turn the light up so you can see what you're doing. So practice. Can you do all of these things? So do me a favor and check your answers. Show me that you got everything that I did. I try to include my work where I multiplied in number 3, where I distributed the negative in number 2. I also included the domain restriction in number 4, because you know x can't be -1. Okay? Your only homework over spring break is to get both benchmark tests completed online. I am not available after Saturday. I'm telling you that. Please listen. I cannot help you after Saturday because I'm going to be in a different state. I'm not. So you got to get these online benchmark tests done. Okay? I'm coming in on Monday, and they better be finished. But Monday better be like they're done already, because I got to put the grades. My grades are due Monday. The Monday after Easter, the Monday teacher work day. So you have all of spring break to work on it, but don't email me and say I can't do it. I have computer problems. You've had 2 weeks before spring break to work on it. You know, Patrick. The benchmarks, do we do it at every session? You save it, and then I can see your grade once it's done. Huh? Did you finish both of them? I'll look right now.